All right, hi. I'm Jonathan. I'm first year in the computational analysis and public policy program. It's a long word, but really we study public policy and computer science, like Alex mentioned. I got into data viz by way of photojournalism, right? So I spent a couple of years thinking about how best to visually illustrate news stories and actually go out and photographing them. And as my work got more computational, so has the illustration. Anyway, so today I want to talk to you about solar energy. Specifically, I'm really interested in this because if you care about this sort of stuff, solar energy is kind of the source of renewable energy that's most participatory, right? So if you can't like dam up your local stream, you can't install a wind turbine in your backyard, but you can. People do buy solar panels. Actually, I'm actually really interested. Can I see a show of hands if anyone in this room actually owns solar panels for their house? No. You? Your parents? Okay. My parents do as well. Really? Awesome. Yeah. I'll talk about this later. But Illinois, not a great place for solar panels, as you might imagine. But yeah. So I mean, then there's a policy angle too there, right? Because if we can agree that owning a set of solar panels is a net benefit for society, and maybe that's not true, I don't know. But we'll just take that as assumption. Right now, that's. Then as policymakers, we want to figure out how we can incentivize that on an individual level. What's happening? On an individual level, how do you incentivize that, and on a state level, how do you incentivize that? So that's what I want to talk about today. So primarily, I'm really interested in. The structure of this assignment was that we were going to use this to learn all about a new subject area, right? So something you know nothing about. So I picked this because I had sort of a budding interest in it. And what this scrolly telling piece is going to do is going to walk you through my data exploration process. Because I jumped into it knowing nothing about it, not knowing nothing about what I would find. And so you're going to see about 4 or 5 charts, and they're not particularly like amazing, but I'm focusing on really simple, smooth transitions through D3 and scrolly telling. So that's what I'm going to try to do here today. So jumping right into it. So these are all the different sources of solar and renewable energy in the U.S. over the last 30 years, and how much we've generated every year. And I want to focus specifically on sources of solar energy, right? So these are grouped by the type of energy and then who generates them. So you have utility, you have residential, you have commercial, and you have industrial. I'm sorry, you might not be able to see maybe you can. But specifically, I want to talk about residential because it's solar energy is the only category of renewable energy that has a residential line item in the official data. And so that's really interesting, right? We as individuals actually can do something in this area to contribute to national supply. And that's not something you can say in any other area of energy, I think. So looking specifically at solar and residential solar, I want to know where is it being generated, right, in the U.S., how much, where, in which state, and by how much. So what this does is it's saying how much solar energy is being generated in each state relative to the median. And so in 2016, the median was Iowa. The top 3 at the top end here all make sense, So this is solar energy per capita, so I'm controlling for the number of people in the state as well. So Hawaii, Arizona, California, that all makes sense, right? They're all really sunny places. The next few don't. So I don't know if you can see this, but I'm going to read them off. So after that is Nevada, which is fine. Vermont, Massachusetts, New Jersey, Maryland, Connecticut. That's a little weirder. I saw that, I was like, okay, that's a little strange. In my mind, they're not really sunny places, and that's where you should have solar panels, where the sun does shine. So I wanted to ask, why is that? And so I wanted to look at how much sun each of these actually get, and compared to how much solar energy they produce. Whoops, wrong way. So on the x-axis here, we have global horizontal irradiance, just a measure of how much sunlight on average you get in the year. And on the y-axis, you have again solar energy generated per capita. And so overall, you see that these sort of follow a slight upward trend if you look at the very unscientific trend line there. Again, at the top, I'm just going to call these out again because you might not be able to see the labels, but Hawaii, California, Arizona, these make sense. And as you go down here, I want to call your attention to the ones in purple. These are states that are all in the Northeast. And when I say Northeast, these are the census region classifications. They're all sort of in the Northeast of the country: Vermont, Massachusetts, Connecticut, New Jersey. And so this is saying that for some reason, even though those states are getting such little sunlight, they're also generating a lot more solar energy than what you might expect for the amount of sun they get, which is weird. It's still strange. And so that, there were more questions that came out of this. And given that you can't really change the amount of sunlight you get in a year, how do you generate more energy from that, right? So in my mind, the simplest way to do that is to just have more solar panels per capita, right? And so I wanted to verify that. Do they actually have more panels? Thankfully, there's data on that. Unfortunately, that line is not going to go away. But please pretend like it did. So I looked at the number of solar panels per capita in each state as of 2016. And if you look at the purple bars, those are the Northeast states. Yeah, and so it turns out, yes, for some reason, the states that are roughly geographically in the Northeast have really high rates of solar panel adoption compared to what you might expect. The highest, I believe, is Massachusetts with 95 solar panels per 10,000 residents, going all the way down to Maine, understandably, down there. So we've learned a couple of things, right? Number one, residential solar is a really big big contributor to total solar energy in the U.S. Number two, a lot of it is being generated in non-sunny states for some reason. And number three, those non-sunny states have a lot of solar panels. So I wanted to find an elegant way to put this all together, because one of the things about data viz is that it allows you to present a lot of like information at one go, right? So the last thing I tried was putting it on a map. And so this is when you disaggregate it on a county level. So each circle is a county, and the size of the circle is the amount of solar panels per capita they have, and the color of the circle is the amount of sunlight they get in a year. So on the southwest area, you see big orange circles. That makes sense, right? Lots of sun, lots of solar panels. But on the northeast, again, you see a lot of big purple circles, and indicating that even though it's kind of a gloomy place, you still have a lot of panels per capita. And so that's where this specific part of the project ends. So I should say that this is a series of 5 visualizations, and they're based on this longer static portfolio. How much time do I have?
You're a little over, but.
Okay, great. So in the rest of my portfolio, I go on to look at why this might be. I look at, for example, state level tax. What's the word? Yes, thank you. Tax subsidies and like incentives for solar panel buyers. TLDR. We didn't do a lot of like econometrics, but it doesn't seem to have been driving a lot of solar panel adoption. So it's kind of like a null result. We still report those. But I go into other features down below, and if you want to look at that, there's that link. That link is all the way down here. And it's the static version of everything you've just seen. So thank you. That's my project.
Hello again. I'm Adam Shelton. And again, I'm a first-year master's student in the computational social science program. So a little different from some of my other peers here. And again, I'm really interested in technology and specifically inequality. So I started to sort of look into this relationship a little bit. Start off, the internet's pretty important, right? Like we use it for communication, learning new skills, filing your taxes, and getting a job, and sometimes even losing a job on the internet. And that's great for all of us that have internet access. But there's a large portion of the United States that actually doesn't have internet access, 93%, which is about 21 million people who don't have any internet access. And this obviously affects the opportunities they have. And again, if you look at this cartogram, you can see that a lot of the counties that have a lower percentage of people that have internet are sort of in rural, impoverished counties. which we'll dive into a little bit more in a bit. But not only do a large portion of America not have internet, an even larger portion of America doesn't have broadband internet access, which is defined by the FCC as 25 megabits per second download or 3 megabits per second upload, which is kind of slow. And so that definitely affects, what you can do and what opportunities you have in your area, and especially for businesses. Businesses depend on fast, dependable internet connections. And if you don't have that in your area, it's going to be much harder for businesses to conduct business in the 21st century. So again, here's one of the implications. Let's see if I can full screen this real quick. So this is looking at counties and percent without internet against percent below the poverty line. You can see there's this very strong correlation. And then I've highlighted the top 10 most populous counties in the United States. So Kings County, which encompasses the Queens borough in New York City. Again, Cook County, which encompasses Chicago. So even in these large metropolitan areas, you can still see this relationship of that the more poverty there is, the less access to internet that it has. And that obviously has serious implications because people in impoverished areas are already, they don't have all the opportunities that people in other areas have. And now they have even less because they don't have as good of internet access. But again, there's some good news. Download speeds have increased from 2015 to 2018. So you can see that's in large part due to gigabit internet really taking off. But still a large portion of, this is just internet users in urban areas, still don't have internet faster than the FCC download speed cutoff. Again, this is largely in part due to larger adoption of fiber to the home internet, which has steadily grown over the last couple of years. And again, you get into this conversation about value, and when you're on a limited budget, better value internet means you can get better internet for the same amount of money. And so you see a lot of these market disruptors like Google Fiber over there towards the right side that have extremely good value. But a lot of ISPs that use older technologies like DSL have very bad value. So if you're in an area that only has DSL, again, that affects what you can do. So I want to explore this a little more. So again, I made an interactive sort of scrolly teller to go through it, and it highlights a few of these relationships between internet access and technology and the social impacts. Just barely fits. Okay, so it's again, it's a cartogram with two variables. So you have a technology variable that is on a color scale and a demographic variable that's on an opacity scale. And basically you can see sort of the interaction of these two variables. And then there's a little histogram to show you sort of what the distribution is looking like. So again, this is percent with no internet and percent below the poverty line. And you can see, especially in the rural South right here, you have these high amounts of poverty and higher areas where there's no internet access at all. Okay. And again, you can see sort of a similar relationship with just broadband speeds as well. And so again, here's unemployment. Again, so it's sort of expected that you're going to have higher levels of unemployment where there's higher levels of poverty. But I mean, again, this relationship stands, and that's impactful. Again, when a lot of jobs are online and a lot of job postings are online, and if you don't have internet access, that means you don't have access to those jobs. And then again, looking at race. So again, people of color are mostly in the rural South and Southwest. And again, you can see they're also impacted by this in a similar way. And again, specifically looking at like Native American areas where there's a high amount of Native Americans, specifically on the reservations, they have like higher rates, or sorry, lower rates of broadband internet access. Again, so looking at this relationship of like multiple devices, so the theory being that if you only have a smartphone, again, like if you don't have a lot of income, you're probably only going to have a smartphone because computers are expensive, and a smartphone can do 90% of what you need to do. And so again, you see a similar relationship where in higher levels of income, you're less likely to only have a smartphone. So you're going to have a few different devices. Again, higher housing costs sort of, again, are proportional to better access to internet, which makes sense. This is a little bit of like a weaker relationship, but sort of this idea that like older Americans are usually only own a desktop, and you can see a little bit of that relationship here. And then again, I just sort of ended it with an interactive portion. So like if you want to explore different things, you can do that, and it allows people to, once they've gone through sort of this narrative and learned how this works, to find things on their own. And I actually made this as one of the first things so I could find some of these relationships on my own too, because it's a large amount of data when you're looking at the entire United States, and it's hard to parse out without having a good visualization like this to do it. Yeah, that's it.
But hello, my name is Dan Snow. I'm a second-year MPP student and a research assistant at the Center for Spatial Data Science at UChicago. I did my project on the shortage of US physicians, mostly in rural areas, but actually that's kind of a myth, and then we'll get into that. But basically, my research has focused on healthcare, the shortage of doctors, and the spatial accessibility to healthcare, and specifically to primary care physicians. So the US has a huge problem. Rural parts of the US just have a massive shortage of physicians compared to urban parts, and it's only getting worse. Basically, physicians are getting older. Rural physicians in general are older than urban ones, and those physicians are retiring or dying off, and they're not being replaced by new medical school graduates. So that's the problem that we're going to explore. So I've done a write-up. I didn't have a cool presentation, sorry, but I have a really long write-up. And actually, please read the article if you... Okay. So basically, there's this sort of myth, or like commonly held knowledge, that the US does have a rural physician shortage, and it's actually sort of not true. The actual physician shortage in the US is not in rural areas, it's in uneducated areas, or low education areas. So if you look at this map, this is basically just physicians per 100K, it's just physician population density. You can see that large portions of the northeastern US actually have super high physician density, right? Why is that? Those areas are actually really rural. You know, Maine is a really rural state, no matter how you quantify rurality. Same is true of Vermont. And yet they have really great physician density. And it's because actually doctors just really prefer living around other educated people. They have a really high degree of homophily, and they congregate in cities like most other highly educated people, and that's what is leading to the shortage. But those northeastern areas are actually very highly educated compared to other rural areas in the US, and so they don't have the same shortage characteristics as, say, rural Iowa or the mountain states. That's a little hard to discern from this map, but this map is possibly the one that I'm most proud of in my entire project. So basically, this is access to primary care as a function of the distance that you have to drive to see a physician and the patient load on that physician once you get there. So if it's minimizing that across a graph of the entire United States, at the census tract level, this is aggregated up to the county. And basically, areas that have really great accessibility, so you drive a short time and you don't wait very long to see a doctor, will be purple. And as you can see, highly educated areas that are still rural have really great accessibility. So the entire northeastern US, Minnesota, which has the Mayo Clinic, the Pacific Northwest, they all actually have great accessibility despite being very, very rural. And conversely, you can see areas that are actually fairly well populated, right? They're not super rural, don't have great accessibility. So most of the South, the plain states, Nevada and the desert kind of states, they have terrible accessibility to primary care. So that is a huge problem. I mentioned this already. This is the other half of that problem, right? So for the rest of this presentation, I guess I'll just use rural as a sort of shorthand for uneducated areas. For the most part, there's a lot of overlap, and so these trends are true also for rural areas. But basically, this is the age distribution of urban and rural physicians. Rural physicians tend to be way older than urban physicians, and as I said before, they're just not being replaced. So in the next 20 or so years, as all these physicians retire, we're gonna run into a huge problem. I'm sure you guys have seen, oh wow, really? I'm sure you guys have seen New York Times reporting on hospital closures, stuff like that. This is that problem, essentially, right? Doctors just don't want to live in rural areas. I might go a little over. I got a long thing, sorry. And this is another part of that problem, right? So more and more doctors are going into specialty care, and those specialists are almost always located in cities, right? Rural hospitals just can't support specialist physicians. They don't have the demand and they don't have the infrastructure. And also medical school is getting more and more expensive, and so more physicians or medical students are opting into those specialty positions. Contrary to popular belief, this is not driven by a wage differential. So rural doctors actually make significantly more money than urban doctors. They're subsidized in various ways by the federal government, and they actually make around 40 or 50K more compared to a urban doctor, and this is not adjusted for cost of living. So this difference gets even wider when it's adjusted. It becomes like 60 or 70K. So one of the big drivers of doctors moving to urban areas, we think, is basically that they are forced mechanically to do their residency and go to medical school in urban areas. So there are no medical schools in really rural areas. There are medical programs and affiliate programs, but there's no actual schools, right? And so no matter where you're from, you end up going to medical school in an urban area, and you basically have to do your residency in an urban area. There's just way fewer residencies that are rural specific. And then after you've completed medical school and your residency, people just don't go back. They do a little bit, but just not to the extent that you would hope. I'm going to skip this one for time. And so what's the solution here? Well, it's difficult. Wage premiums don't work. And so the solution that has been proposed by the AMA and a lot of medical schools is to have rural programs. Basically, you train doctors in rural areas and hope that they stay there. Those don't seem to work either. And so my proposed solution is basically twofold. One, you recruit medical students that are from rural areas that have a pre-developed preference for those rural areas. Those students we found are most likely to return. And two, you just recruit more NPs, right? NPs, for the most part, can serve as a substitute for a primary care physician. And in states that have a lot of NPs, we see them serving as substitutes for doctors, right? So that's this plot. It's a little hard to interpret and read, but, and then I'll be very brief. And so, refresh this. And so we wanted to know if those rural medical schools were actually sending more students to urban areas or to rural areas. And the answer is yes, but they don't really stay there. And so I made this interactive map that was based on a map that my coworker made that was static. And it basically shows where students from every medical school end up in the country after they graduate. So this is their practice location. And if we want to do Pritzker, University of Chicago, we can just click on that point. And this is where all the students from Pritzker end up in the country. And they're added to this list on the right-hand side. If you want to see where students from an entire region end up, say we're interested in this rural area, we can do a lasso selection. And here are all the students from sort of the Midwest, right? And you can see they kind of end up in the same locations that they go to school, right? And that's also true of the coasts. So if we do New York, people pretty much just stay in New York, right? There's a lot of schools there, and they all pretty much stay there. And then I'll conclude, this is the top 10 medical schools by US News. And this is the problem, right? These are the best medical schools in the country, and they're just not sending people to rural areas at all, right? Those people have really great outside options. They can practice pretty much anywhere they want, and they all go to the coasts. So in conclusion, recruit more people from rural areas and hire some more NPs for your rural practices. Thank you.
Hi everybody, my name is Corey. I'm a second-year MPP student at the Harris School. I moved here from DC. I'm from California originally. I'd never lived in Chicago, so I wanted to do a presentation that helped me get to know Chicago better, and I'm also interested in urban issues and sort of urban systems, how large social trends kind of ripple through the different ways that cities interact with each other. So what I looked at was this major demographic shift that's happening in Chicago. Over the last 20 years or so, Chicago has gained about 500,000 new white residents, while minority populations have remained steady or fallen. So I wanted to know what that looked like. Where are all the white people moving? We hear about the top gentrifying neighborhoods like Pilsen, but as it turns out, white people are pretty much moving everywhere. This is a scatter plot just showing every neighborhood in Chicago. The x-axis is percentage change 2000 to 2017 in white population, and the y-axis is that same percentage change in black population. I just chose African Americans specifically because I could only do one extra variable, and they represented the largest minority group in Chicago. So as you can see, the majority of Chicago neighborhoods are clustered in that lower right-hand quadrant, indicating an increase in the relative percentage of white population and a decrease in the relative percentage of black population. And interestingly, a lot of these outlier neighborhoods down here are former housing projects, where I think beginning in the early 2000s, the predominantly African-American residents there were forcibly relocated. So I think that's what put them there the most. And then I've got a little handy map so you can see that it's not really clustered in any one area. These neighborhoods that fit in this quadrant are pretty evenly distributed. So alongside this sort of demographic shift is an economic trend of divergence. So I use that above plot. The first two plots were just from American Community Survey census data. This one is using home value index from Zillow. And so I just ranked the neighborhoods relative to all the other neighborhoods in Chicago by their home value, and I found the most sharply, or the four neighborhoods with the largest shift. So the top two gaining the highest in home value, and the highest number of ranks in home value, and then the two that are losing the highest ranks. So in 1995, these four neighborhoods are all relatively close together, sort of middle income neighborhoods, and we see up to 2017 or 2019, two neighborhoods, Bowmanville and Loganville, have experienced, Logan Square, have experienced a sharp increase in home value relative to others, while two others, Dunning and Garfield Ridge, have gone down. So I just anecdotally kind of Googled around to try to see what I could find. I'd never heard of Bowmanville before, but apparently it's right next to Lincoln Square and Andersonville, which are very popular, hot housing markets, and they're capturing sort of the spillover of people that want to be near those areas, but maybe want to pay a little bit less. Dunning and Garfield Ridge are just sort of on the edge, and I think they're having some movement of mostly white populations to the suburbs. So that could be one thing that's driving the decrease in home values there. One proxy of sort of economic activity or economic health of a neighborhood might be the residential construction. If land in a neighborhood is expensive, you'd see probably a lot of new residential permit construction and maybe some churn, so some demolition and construction. So the near north side, I don't even know what the neighborhoods are. I think it's near north side, but sort of Lakeview and Lincoln Park have a lot of churn, so a lot of construction and demolition. Places like Logan Square are predominantly construction. And then the south side, like Inglewood, is mostly demolition. And I'll show you lower down, but that is mostly driven by targeted demolition initiatives by the city, where they'll tear down blighted or vacant homes to cut down on crime. So you don't really get a sort of time series element. This is building permit data, I think 2006 to 2019 from the open data portal. So I wanted Chicago's open data portal, so I wanted to see what that looked like over time. So we've got year on the x-axis or the y-axis, and then it's a diverging bar plot. So in both directions, it's the number of permits. And we see that before the recession, there was a huge amount of construction that plummets during the recession and then kind of comes up again. Demolition, a similar sort of trend, but then once the city started doing this demolition program, they shot up and stayed even. One thing that was interesting to me is if you read these blogs about the future of Chicago housing, you see like deconversion a lot, where families are moving in, tearing down multifamily homes, and then building single-family homes. What I'm noticing from this data here is that an increasing percentage of new residential construction is actually in multifamily homes. The classification was just string parsing of the permit description. And fewer of the demolitions are multi-unit homes. So it could be possible that this deconversion process isn't happening through a formal permitting application, but that pattern seems to belie that statement. Thank you very much.
So my name is Mario. I'm also a second-year graduate student at the University of Chicago in computational analysis and public policy. Throughout my career, I've worked on immigration issues, drug policy issues, and health policy, public health mainly. And I wanted to sort of take a look at Central American migration within the context of the migrant caravans that are sort of in the news and this humanitarian crisis on the border. And so the data that I used is two surveys, one of people in country in Honduras and Guatemala and El Salvador, measuring perceptions of violence, plans to emigrate, things of that nature, and then a survey of Central American migrants supported from the US that tracks their movement through Mexico, which was pretty interesting to get my hands on. But sort of to set the context, there's this big shift across all Central American countries of people planning to emigrate within the next 3 years, and that's most notable in Honduras and El Salvador, not as much in Guatemala, which sort of tracks with the trend of migrant caravans that we've seen, mostly made up of people from these two countries. I tried to get into some of the reasons why these folks were planning to immigrate. Those planning to immigrate, this graph could be represented in a better way, but those planning to immigrate are dark purple. Those who are not are pink. People who plan to immigrate don't trust the justice system at far higher rates than those who do. They tend to be younger than those who do. They don't trust their neighbors at higher rates than those who plan to stay. Interestingly, it seems to be that economics is not a big part of the reason to emigrate. People are more likely to be fleeing violence than they are to be escaping a situation of poverty, at least according to this survey data. once they do decide to emigrate, this is for Hondurans in particular, the price of the journey, or for all three, the price of the journey is increasing. So the price that they pay to traffickers to get them through Mexico has increased exponentially for Hondurans, and Guatemalans, well, it's stayed relatively constant for Salvadorians. So even in situations of poverty, these people are willing to shell out up to $6,000 to get through Mexico, not entirely safely. So once they get into Mexico, I wanted to take a look at the routes that they take and compare that to the route of the migrant caravans, which is actually fairly different from what people typically take. So this is the route of the October 13th migrant caravan. If you'll note, it hugs the Pacific coast of Mexico, which is really a strange thing for it to do. That route is twice as long as if it just went along the Gulf of Mexico. And in fact, if you look at survey data of migrants in 2017, they tended to stick. This is the concentration of migrants naming these cities on their journey. They tended to stick in routes that hugged the Gulf of Mexico. The traditional route is to enter through Reynosa. 3,000 migrants in the survey named Reynosa as their port of entry into the U.S. 381 in Veracruz as a stop along the way, whereas only 117 named Tijuana as a stop on the route. So migrants, when they don't move in caravans, tend to move across the Gulf of Mexico, which makes sense. It's a shorter route. So why did the migrant caravan choose to take a path that was different? And that was a very purposeful decision. Actually, the migrant caravan was a fairly organized entity in the sense that they had meetings once they got to Mexico City to talk through what route they were going to take to get to the U.S. border. And they realized that this traditional Gulf of Mexico route is one of the most violent trajectories that any human being can make. More than 54% of migrants who named Veracruz as a stop on the route experienced some sort of violence on the way. 39% of those who entered through Tamaulipas experienced some sort of violence along the way. These numbers are significantly less outside of Jalisco if you go through the Pacific coast. So the takeaway from this is that the migrant caravan was optimized for safety in two ways. One, moving in large groups is protection against criminal actors. But two, by moving in an organized by moving it within the context of an organized movement, they were able to choose a route that maximized their safety on the route to the U.S. That's it.
My name is Natasha Mather, and I'm also a second year in the CAP program. I'm originally from New York, and when I was choosing, when I was choosing a topic to do for this portfolio, I wanted to focus on the New York Police Department. I was able to take advantage of the open data portal there, and they have information on the number of complaints the police receive, the amount of arrests they actually make, and a lot of information from stop and frisk in New York City as well. So I decided to start off by taking a look at when crimes take place. And although you often worry about crime like late at night or early in the morning, the NYPD actually received the most complaints from around 3 to 7 p.m., right when people are getting off work. Just like in Chicago, the number of complaints also increased in the spring and summer and not in the cold winter months. As I was looking through the data, I noticed that there was a huge disparity in which crimes they received a lot of complaints for versus which crimes there are actually a lot of arrests about. When you look at the crimes on this side, harassment 2, which is basically stalking, petite larceny, which is theft under $1,000, and criminal mischief, which are things like graffiti, there are many, many more complaints than there are actual arrests. Contrary to that, for the crimes on this side, they represent a large portion of the number of arrests that are made, but a relatively small number of complaints actually come in. I next wanted to look at stop and frisk specifically. Just to give a little background, stop and frisk was a practice that started in the early 90s by the police commissioner William Bratton and Rudy Giuliani. And stop and frisk meant that a police officer could do what was called a Terry stop, where they could stop someone on the street without a warrant and ask them questions. They could stop anyone for reasons including furtive movements and wearing clothing indicative of a crime, among a long list. So now when you look at who was actually stopped, first of all, about 55% of the people who were stopped were Black, and another 30% were Hispanic. so most of the people stopped were Black or Hispanic. Additionally, a larger proportion of Black and Hispanic people were actually frisked after they were stopped, compared to about 10% less when you look at people who were not Black or Hispanic. One of the goals when stop and frisk was implemented was the idea was that you would stop people before they committed a crime, and also be able to remove any weapons that they had or anything that they could use to commit that crime. However, when you look at the number of stops were made compared to the number of stops that the number of times that they actually found a weapon, you can see that they really found a weapon in a minority of stops. So as I said, stop and frisk began in the early 90s, and it continued to increase every year since then. However, by the late 2000s, the disparities that I showed in the previous graph had inspired people to start protesting against the indignity of stop and frisk more, and this led to protests and marches, mainly at city halls and police departments. This ended up culminating in a silent march to Mayor Bloomberg's apartment in late 2012. You can see that if you just look at 1 year before the march compared to a year after, the number of stops had declined significantly. Finally, I wanted to look at stop and frisk overall. As I mentioned, it continued to increase until 2011, and you can see that the majority of people stopped were Black or Hispanic. One of the factors that influenced the amount of attention that stop and frisk got nationally was a report by a police officer named Adrian Schoolcraft, who recorded his superiors telling him and his coworkers to target people by their ethnicity and to fulfill certain quotas. This was eventually published in the Village Voice and contributed to the protests that happened in the year after that. Many times, people associate the end of stop and frisk with it actually becoming unconstitutional, but that only happened here once the number in late 2013, once the number of stops had decreased significantly. I went into this project thinking that I was going to focus more on crime rates, but instead I was heartened to see that people using their political voice, whether that was through protest or through the election in 2014, can really make a difference even against as established an institution as the New York Police Department. Thank you.
Hi everyone, my name is Elena Stern. I am a second-year student in the Computational Analysis and Public Policy program. Prior to starting graduate school, I was working at an international development research organization called Aid Data that's focused on making international developments more data-driven and effective. So that is what motivated my project. One challenge for those interested in aid effectiveness is international development agencies, of course, all have their own pet ways and pet scales for evaluating their programs, which makes it really hard to sort of crosswalk across agencies and look at broader trends. Fortunately for me, a researcher at Johns Hopkins University went under the painstaking effort of crosswalking the evaluation metrics for 8 of the major international development agencies, including multilateral organizations like the World Bank, or bilateral groups like Department for International Development in the UK, which enabled for the first time a sort of broader comparison of trends across agencies. And that's what I'm diving into in my project. So one thing that we see here is that the majority of projects receive satisfactory rankings. Part of that might be because a lot of these rankings come from internal sort of evaluations that the agencies themselves put on, but even across sort of external evaluators, this trend still holds. However, when you dive deeper, you do see that there are some individual countries that far exceed the global average of 23% of unsatisfactory projects. Those countries are concentrated in sort of New Zealand and Oceania, so small countries where maybe there aren't a lot of projects, and maybe an agency might not be very good at implementing projects in those places. And then secondly, a lot of those projects all those countries with poor performance are concentrated in the African continent. So one very interesting trend that I saw here, let me zoom out a little bit, is that when we look at sort of World Bank investments in particular, there's a clear sort of trend in Africa that across sectors, we see much worse performance across projects in all different sectors in Africa, which I thought was really interesting. So I wanted to dive a little bit deeper into why that might be the case, why we might be seeing these differential trends in Africa. Another thing that I was worried about is that looking at sort of these continent-wide averages or even country-wide averages might be concealing a lot of the variability for a project-by-project level or even looking subnationally in a country. So I wanted to sort of dive a little bit deeper to a more granular geographic level. And fortunately for me, while I was working on this project, the author of the dataset released an update which included sort of the unique project identifiers for the agencies, which let me then link for the World Bank information on project performance with a data set produced by an organization called Aid Data that sort of had been, where the projects have been geographically referenced at the subnational level. So every location that a project works on, a team of intrepid research assistants had painstakingly assigned sort of lat-long coordinates to those projects. So that brings me to my interactive portfolio here. Oh, let me zoom back out to home. Which looks specifically at World Bank investments in Ghana. So what the map here is showing is all of the different locations of World Bank investments in Ghana. So it's a many-to-one relationships. One project might be working in many different locations. And so when you hover over a project here, you can learn more about that project. So the title, start, end date, funding, the sustainable development goal that it's sort of most significantly working towards. For those who might not know, the sustainable development goals are sort of the global development priorities that sort of the world came together and said we want to work towards these goals by 2030. The size of the circle reflects the amount of funding to that project location, which was calculated by sort of taking the total project funding and then averaging it by the number of locations, a rough heuristic because we don't actually know how much was spent in each location. And then the color represents the project performance. So we see a 6 sort of point scale where the worst is highly unsatisfactory, that's your dark orange, and then the best is highly satisfactory up to the dark blue. So one sort of piece of data viz nerdery that I want to highlight is one problem I encountered, which I imagine many of you who've worked with point data have also encountered, is what do you do when a lot of your points are in the same sort of lat-long coordinates? One solution could be to aggregate at the location, but I didn't want to do that because I think a lot of what's interesting about this is project by project. So my approach to dealing with that was to enable the user to click on a location with a lot of projects and then the location sort of dynamically scatter, enabling the user to sort of hover over the different projects and learn about all the different projects in the location. You also see that when you highlight over a location, it highlights in sort of the bar plot the corresponding sort of item in the performance distribution, as well as in the scatter plot above. We've mapped sort of the leaders' prioritization of development sectors based on a survey against the World Bank's prioritization in terms of how much money they're spending in that sector to see sort of where that project falls in terms of the sort of donor and leader priorities. And then if you're also interested, you can sort of click to see the distribution by funding, and again, the hover shows you where it falls in the distribution. Yeah, I will go ahead and stop there.
Hello everyone, my name is Sinclair. I'm a first-year student in that same CAP program. And I think I heard a couple of you say that you're from more traditional software engineering backgrounds and you're trying to do something more meaningful with your software skills. That's where I come from. I did software engineering before this program. Now I'm doing this, so you can do it too. You just have to be prepared to fork over lots of money in tuition. So we're a delegation from Hyde Park. I don't know if anybody else here is also from Hyde Park, but we had this great grocery store, Treasure Island, and it shut down. And so now the options in Hyde Park for grocery shopping are kind of few. We've got Target, we've got Whole Foods, and then there's, yes, if you're willing to walk south, there's another one, but they're not a huge number anymore. And around about the time when I was trying to figure out what I should do, I heard a rumor about Amazon maybe buying Target. So that would have meant I could go to Amazon to get my groceries, or I could go to Amazon to get my groceries. So that didn't seem very exciting. So I started on this project. I called it The Monopolists Are Winning. And I think as you may see, I don't know if that's quite accurate. I think maybe the proper title is Some Monopolists Sometimes Win, but I think that was a little bit less catchy. So this is what I went with. I'm going to start with this graph, and it's a little bit hard to see up here, but what this is showing is a measurement of how different industries are concentrated. And so On the y-axis here, we've got the measurement taken in 2012, and on the x-axis, we've got the measurement taken in 2007. Each of these bubbles represents a different industry according to a classification scheme used by the Census Bureau called the NAICS scheme. And you can see that everything in the top left has become more concentrated since 2007, and everything in the bottom right has become more concentrated. So it's not like everything has moved up into that top left corner, but some industries have, and there are a couple of outliers here. So there's this industry called the agencies, brokerages, and other insurance industry has become a lot more concentrated in just those 5 years. But there isn't really an obvious overall effect here. But I wanted to dive more into that, and I wanted to show the data going back a few more years. But I realized that'd be quite difficult to do with just a bunch of static pictures. So I think this is where maybe we get an illustration of the power of using something like d3.js to really make your visualizations interactive, and you can just fit a lot more in there. So I took this graph and I decided to turn it into this interactive visualization. I also had to do it to get a passing grade in the class. And so this is going to be difficult to read for everybody, but that's that same scatter plot on the left. But as you scroll down, it plots data. So this, you can see the two axes now are still, they're both 2002. So as you would expect, this is two measurements on two different axes. So everything lines up along that one line. And in this case, we're looking at different sectors. So this classification scheme, the NAICS classification scheme, it's hierarchical. So it starts right at the top with these big industrial sectors. And these are things like, so this, for example, is finance and insurance. So that's like the whole finance and insurance sector. And this over here is wholesale trade. So these enormous sectors. And you can see that this is kind of the starting line. But then as you scroll down, they start to move a little bit. And the radius here of each circle represents the total revenue for that circle, for that sector. And then finally, we get to down here. So this is comparing 2002 to 2012. And so there's not a huge amount of movement, but you can see that there is a little bit of a movement toward that upper left quadrant. I wanted to dig a little bit deeper, though. So I drilled down that NAICS hierarchy to look at a lower grouping. And so this is now we're looking at industries instead of sectors. So this legend down here is still showing you sectors, but now it highlights different industries within that sector. And so now we're back to 2002, our starting line. But as you go down, you see that there's a huge amount of divergence. So there are some industries here that get a lot more concentrated, and there are other industries that become less concentrated. And this shows you the 10 years between 2002 and 2012, what happened. And there's this crazy outlier here, which became enormously more concentrated, and that's insurance and pension funds. But there are a couple more here. Waste collection grew more concentrated. Business school. Coal mining. Performing arts companies. So I was pretty happy with this. I think what I would really have loved to have done, this data comes from the Census Bureau, and they've got data going back quite a ways, but everything before 2002 is in PDFs, so I didn't have time to figure out how to get that data out of the PDFs. But I would have liked to, because I think the trend would have been clearer if I'd had the opportunity to go back further. But yeah, that's my project. Thanks a lot.